Now this came about today because I noticed this quantum battery. This is by a person named Mayan Royal. And there's a video we're going to watch in a second. Quantum battery never loses its charge. The battery works by harnessing the power of excitonic energy, state in which an electron absorbs sufficiently charged photons of light. That's exactly what we are doing. Alright, we may have the forever battery right here. Fermilab says there's a fixed particle that looks just like this. It's fixed, never changes, and then there's a gushy one like that. They're exactly correct. That's the black one right there, and this is the gushy one. And this is a photon. I don't know if I told you before, but that's a photon of light. And we picked this up in our research by watching light accelerate, and I believe it's accelerating. I mean, if that's not accelerating, I don't know what it's doing. And as the light passed and accelerated through this venturi, the particle began to expose itself, which has never been seen before, and the black became quite apparent. And you see these little white particles here? That is the push against this leading tip. This will flip to the back, this will come to the front as this charges up. That's what the muon wobble is, and that's this here, coming forward. Now, what else did we do here? We could see at the venturi, the white continued all by itself and the black balls went around, and here is that right here. You see the black balls right here? They can't get through this venturi. We separated the charges, and that is exactly what a battery does. Now that is called the muon neutrino electron neutrino. Now not only did we separate the charges, we separated the muon from the electron. We really created nuclear fission and fusion. This is fission right here. This is fission. That particle separated. That's fission. It came back together. That's fusion. Well, that's what it is. And that the particle right in between here, that is like raw electron energy. And I can't imagine how powerful it is, but I'm going to tell you that's going to be powerful, because it's completely separated from its partner, which was the dark matter. The two of them together make up static and lightning and all of that stuff. I don't think it's just the white one that we're getting hit with, although that's possible. But because I know they can separate, we can see them separate. So there's no question they can separate. What is actually electricity? The top physicists don't even know what electrons are made out of. They have no clue right now. They don't know what the mass is. They don't know what gravity is. Nothing, because they don't understand electron flood theory. And electron flood theory is as simple as that right there. That's the whole thing. Everything's made of these particles. The ones that are right here. Everything's made of these particles. One of them is this. Two of them back to back make up a photon. Nothing could be more simple. And we can see them right there. It's not like a big mystery. There it is. That's the particle. I mean, we're not talking, I guess we are talking rocket science. All right, here's my device. As simple as that. We're separating these white ones from the black ones. The black ones go around. We got to intervene right in here and get the white ones, because they want to be back to the black ones. Then we send them through our batteries and whatever. They go through our load, which is lights, motors, cars, whatever, and they come back to the other side, and that's our circuit. Now, we use a little tiny bit of that, zip, zip, to keep the laser going, and this is free energy. And this can be done within a matter of a couple of weeks. Literally, everything's off the shelf right now. It just has to be engineered. You got to create the correct venturi, the right materials. And, there's a little bit of engineering to do, but not much. And I think we could get free energy. And if we could, I think that would make a big difference in everything in the world, because basically the world runs on energy, and we have destroyed the world trying to get it. And it's just been sitting here in our laps forever for free, as far as I'm concerned. What I'm looking at sure looks like it's going to work to me. Now let's go see about that never-ending battery. Okay, this really caught my eye. This is called self-charging quantum batteries will transform the world. And if that's true, which is, I just showed you how I think ours could. This is called the electric Viking. And this just came out, and I'm just going to let it play. I haven't watched this yet, but they're talking about photons creating electricity, and absolutely, there's no question you can do that. I can show you that in great detail, which I think I already have with my light experiments. But all you have to do is shine a strong enough light on a CMOS like this right here. I could show this later, and I will. Whoops, I'll show, taking a meter, attaching it to one of those little LEDs, and then shine light on it, and you'll get voltage. So there's a whole bunch of different ways to create electrons. That's my point. But this is new technology he's talking about. There used to be NiCad batteries and lithium ion and all these different, lead acid. All they are is chemical interactions. Now, chemicals are made of literally particles that are electrons and what they used to call protons, but they're not. They're dipole electrons. That I will show as well. And a nucleus is made up of this. Not one big giant ball of positiveness like this. Nucleuses are made up of all little electrons. Every one of those is an electron, and it is a dipole. Now because that's the only way this can work. And I have shown this over and over. So hopefully this will make sense. I hope this guy's going to be coming along with something, because he's talking about photons creating the energy, and that's exactly what I'm showing.
There is this new concept which has been recently worked on by a number of different researchers all across the world. In particular, researchers here in Australia, in Adelaide, and also some researchers in Italy, but others have played a part in other places globally as well. The idea is the quantum battery. If the quantum battery is actually possible, we will know within the next 12 months.
You could learn 30
I believe
days.
It is. But then again, I'm not one of the smartest people when it comes to physics, so I could be wrong. However, this is the way I see things, right? 50 years time from now, the Jetsons, we're going to have quantum batteries which will make our current battery technology look like horse and cart. And I mean that. The exciting news is that quantum batteries are now much closer to reality, with proof of the idea of super absorption by an international team of researchers. The discovery will pave the way for a class of batteries that charge faster the bigger they get. So if you put a massive battery, right, in a huge truck, it's going to charge faster than the battery in a small car. Makes perfect sense. Another amazing feature of quantum batteries is their potential to charge just from ambient light in a room. They don't even need the sun. Super absorption is the idea that the rate at which the light can be absorbed by the molecule actually increases as you increase the number of molecules, explains Dr. James Quaish, a researcher at the University of Adelaide, and lead author on a paper describing the research published in Science Advances.
All right, I just want to make one statement right now. Obviously, the bigger the surface of what you're hitting with light or heat or anything, the quicker it's going to absorb it. Now, well, it's not going to absorb it quicker. It's just going to absorb more of it because you have more surface. Now, but to get it back out of there in an energetic value, you have to have potential. You have to have voltage. Amperage is something totally different. You can flush a ton of electrons in there, that's fine. But if they have no push, you got really no electric energy. All right, this is as simple as it gets. This is a basic battery. You have what they call an anode here, which has extra electrons. They want to get to the cathode, but they can't because there's a membrane in between, an electrolyte. So they have to go around to get to this side. Well, guess what we did? If we shoot our laser into here and we put that venturi right there, and then on the other side, we take these electrons, because they'll come through, the positives won't. The positives will have to go around to get through to the negatives. So the negatives will go through, and they will be at this side ready to absorb the positives. And that's how we're going to flow it. It's a little confusing, I know. But the whole thing is to separate the negatives from the positives. Now this is about as certain as you can get that we have separated. We started with light here. No question whatsoever that we didn't have gigantic particles like CERN and Fermilab. They have seen these same particles that I'm showing you here, identical same particles. Only they started with billions of particles at the same time, and they have seen these, but they also see a ton of other ones that maybe 3 or 4 or 5 of these together, or a half of one of these, or crazy, and they call it a particle zoo. Really, when only 2 particles exist are these 2. And when you start building them together, you build up all kinds of different matter, basically, different sizes of molecules and atoms and so forth. But this is a complete separation of those 2 particles. Virtually no question. If you can harvest it here and say you can't get this white until you come around to get through our device and get back to it, as I showed before, right here. All we have to do is say, no, you cannot have the white until you go through our device. So we get through here, and the blacks say, okay, let the white go. The white comes through here, and it says, all right, grab a hold of those whites and tell anybody's on the other side of the device they can have the white back, but you got to get through the device first. And zip, that's what happens. Now, we use a little of this to come back to run the laser, and it just never stops. And you could have 10, 20, 30, 40, 50 of these lasers in a row, because I'm telling you right now, they're as small as this. And these give off literally, well, I'm going to actually show you this happening with a meter right now, with light from a laser, or even from a regular light, shining into one of these, how much voltage it will put out. And if you string voltage in series, it gives you higher and higher voltage. Parallel voltage gives you more current, so you have more electrons flowing at the same voltage. But when you go one right after another, it keeps building and building and building, and you go to 1.5 volts, 3 volts, 4.5, 6, that type of thing. And that usually they're 1.5 volt, 1.5 volt batteries like this. All right, but if you take a 9 volt battery and broke it apart, you're going to see the little tiny flat button batteries. There's going to be 6 of them in there. It makes 9 volts. And this is 1.5 volts. So that's the way batteries work. There's a little trickiness to this, but not a whole lot. Again, this is pretty simple stuff. When you understand electron flood theory, when you don't understand electron flood theory, everything, and nobody understands anything now because they don't understand gravity, they don't understand heat, light, nothing. Totally, and you can never understand it until you understand that everything is made of these 2 particles, which are the same ones that Fermilab and CERN see, but that's the only ones that exist, are those 2. That's the only ones. Okay, we happy with that? I am. All right, so, and I could show you this stuff. I'm not guessing. Okay, shown this a million times. What we're going to be looking at is light coming through the air, which is made of 2, what we would have always called electrons. But they have a dark side. Nobody's ever seen this before. We always just thought it was an electron pushing stuff and making things glow. Well, the 2 of them together are actually an electron. They call them a muon, an electron neutrino. Now, together they make a photon, back to back, 2 of these electrons. And 1839 of these electrons make a hydrogen core, which would be 1 proton. And that, because then it's a dipole. It's not a single positive charge. It just never would work and have 1 tiny little negative charge. No, they're all dipoles, and this has enough at 1839 or 1840, so somewhere around there, to say I don't want any more in here. I will take 1 you can hang around out the outside. That's called the quantum distance, and 1 I'll hang around. Now, can I show these particles? Absolutely I can. And where are they? Here they are. Can we get free energy from them? I think we can. As far as I could see, but it just needs to be engineered and put together, and I would say within 30 days we're off to the races. This is light coming through the air. Every single thing there is has electrons attached to it. Normally they're fairly well glued together. They don't come apart easily. So when we put through a Venturi, which is called an atomizer, what does that mean? It breaks things down into their atomic values, which, and when we're using light, we're photonizing it. We're breaking it from its photon nature, which is this four-banger here, we're breaking that down to the whites and the blacks. And the whites come through the venturi, the blacks will not. The blacks go around. All right, so we have separated those two particles. They're completely separated, totally 100%, which means fission. They came back together here means fusion. They want to be back together so desperately that if we can route them back here to get them back to the black, we've got unlimited power. And they say it's 200 times more than the power we started with if we can split them, and we did. All right, now everybody knows about the LED lights. All the LED lights now, they have these little chips in them. You may not have seen it because normally they look like a light bulb. But if you look up under here, this is the type of light I have here. You see all those little lights? Now, and this is actually a piece from one of those that I took apart and to see if I could create electricity with it, and absolutely I can, and I can create a hell of a lot of it. Watch this. I'm taking a really cheap little blue laser. I'm going to shine it on this one right here, just one. Now I'm on a 20 volt scale and I'm looking for voltage, and watch that. Look at that thing. When I hit it, excuse me, when I'm right on it, look, 2.43 volts. That's huge. Now, don't forget, I think I told you, amperage and voltage, two different things. Voltage is how much push you have. Amperage is how much quantity, the number of electrons that are flowing. Now, I'm on the 2 scale, and I am on DC milliamps. Now, watch this. I'm going to, just keep your eye on there. I'm going to hit this with the laser. You see that? 0.95 volts. I mean, amps. Now, hold on a second. All right, 0.0 whatever, 0.086. That's still a lot, because you could have a ton of these in a row. And the brighter the laser, the more powerful the laser, the more you're going to get out of it. In addition to that, these are only designed to create light. There's new perovskites, I believe they call them, which are thin metal, transition metal conductors that suck up every single ounce of electricity that you can put in there, light. And they are making huge increases in the amount of reaction to sunlight. Because right now, solar panels, they don't collect a lot. I think 28% is about tops you can get. And that is really stretching it, I think. Maybe they made some advancements, but I don't think so. Now, the perovskites, I think we could probably get up 60, 70, even more percent using it, because they're transition metals. They have deep electron orbitals that are unfulfilled, and they will accept these electrons if they are pushed into them. And then once you do, you put them through your circuit, and to get them back to the black, they have to go through our devices. All right, and it's as simple as this. This is the laser. This is the venturi. There's two round pins here, very close together, that when the fields get in there, they push the black out of the way. You can't get through. You're too big. You're a fixed particle. Now, I decided we could do this with oxygen, too, because oxygen, the O is 29,000 electrons. The hydrogens are only 1,839. Why can't we put them through a venturi and collect hydrogen on one side and the oxygen stays on the other side, because it's too big. It's 29,000 compared to 18. If we made the venturi small enough, we would do the same thing we did here with our light. Okay, and these are actual gases. This is, and what you do is you take water and you turn it into oxygen and hydrogen. Simple as that. And then you can recombine the hydrogen back into combustion. Because hydrogen is absolutely the most explosive thing there is. It really is. Hydrogen itself, when it goes off, you don't even want to be near it. It'll blow your eardrums right out of your head. All right, so even though I'm showing this as hydrogen or water and so forth creating this, there's no difference. Light has a black and white particle attached to it. Hydrogen just has 2 hydrogens attached to 1 oxygen, and they're big chunks. They're like this. These are like this. Hydrogens literally are like this, 1 of each of these. The oxygen is 16 times bigger than this. All right, and it's still one big mass. So, and the white ones, the little white ones want to go around the outside because those are the explosive ones. Anyway, when you put it through the Venturi, is exactly like this Venturi right here. Well, all we're doing is forcing a piston to slam this. And the water is going to squirt out there, only the black ones won't go through, only the hydrogen will. Exactly like we're doing here. Because we're doing nothing more than pulse laser. Bam, 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 bam. The black ones are crushing the white ones through. All right, I think we got free energy.